So let's look at a demo first. So this is a plane. You can rotate and then there's a eraser on this plane. So let's watch. Okay, so let's come back to this. So you can see this is the graph showing the rotating plate, and the eraser is on the plate. Let's look at this. Is just a simplified graph, and I can draw a free body diagram on it. So this is a eraser with mass m equals 0.10 kg, and the mu is actually the static friction coefficient of friction between the eraser and the plate. So we have Fn and Fg, they should be equal, but because in this direction there is no motion. So the motion is only like circular motion, so the center is right here. As we said earlier, whenever circular motion, we must have a centripetal acceleration pointing to the center, of course. That's how we call it centripetal acceleration. Then we need to find out which force caused this centripetal acceleration. So actually that's only force is the static friction, FF. So the question asking for what is the maximum speed of the M, so that it stays without skidding. Right, so you can imagine if you rotate the plate and faster and faster, and at some point the eraser is going to fly out. So that means there is a maximum speed. Okay, so then look at this FF. We know the FF must be less and equal than the mu s times the Fn. In this case, the Fn equals the mg, so it equals mu s times mg. And whenever you rotate faster, that means the AC is faster. That means we need a greater FF to provide this acceleration. So the limit is when the FF actually equals the maximum friction. Okay, so we can simply see at this moment the friction, the static friction must at its most maximum value, which is mu s times mg. And this is the friction, static friction provides the acceleration. Of course, it is the centripetal force, which equals the mass times acceleration, which is the centripetal acceleration. And we know the centripetal acceleration equals m v squared over r, so which is AC. Okay, look at this formula here. Mu s equals mg equals m, so I just write here mu s mg equals m v squared over r. So you can see you can cancel the m and isolate the v, so v should be mu s times r, take square root and just plug in. Okay, sorry, I forgot to tell you the r. So the r, let's make 0.3 meter. Okay, so actually you can see you don't really need the mass here to find out the velocity. So mu 0.5 times 0.3, and we calculate. Okay, so 0.3 87 meter per second. What if the question also asks you, let's make this 1 and then 2 and ask you period t. Okay, so what does period mean? It means the time it takes to complete one revolution, just one complete turn. So this time we should do, okay, this is 1, 2 here. So since we already know the speed, so that means if we can calculate how much time it takes to travel one circumference, so that's the t. So t should equal the circumference, which is 2 pi r divided by the v, right? So you can see that's the basic formula, distance over speed. That's gonna be the time, and for one complete revolution. Okay, so let's plug in 2 pi r is 0.3, and the speed is 0.387 equals 4.87 seconds. And also, what if the question asking for angular velocity? So angular velocity, it means how many angles it sweeps over unit time. So number 3. So because we know it sweeps 2 pi over the time t, which is a period. So the angular velocity, normally we use omega. So it's omega equals 2 pi, right? 2 pi, which is 360 degree. That's angle for a complete turn, and divided by the time t. So that's exactly the time it takes to finish one complete turn. So very simple. This one should equal 1.29 radian per second, and that means it's gonna take in 1 second. So the object is gonna sweep over an angle of 1.29 radian, and this is equivalent to if you times 180 degree over pi, so you should get 74 degree approximately degree per second. Okay.